Hello everyone, welcome to our online video tutorial series. Today we will discuss about class 11th topic relation and functions. In this video lesson we will learn about the definition of a function, how does it work and its domain, range and codomain of the various functions. So let's start today's class. So first of all we will understand that what is a function. So as we are aware about the Cartesian product between two sets A and B, then relations are the subsets of Cartesian product. And what is a function? Functions are specific type of relations. That means functions are subsets of relations. So how they are specific and how they are different from the relation, let's try to understand. So first we will know that functions are also known as mapping, correspondence and transformation. So here I made a function machine for you. This x represents the input. So input is always an independent variable. The reason is input we can select, so it's our choice, so it's an independent variable. And this is an output. So output is always an dependent variable because it depends on the input. So input and output, in between that there is a processing. So this is a part of process. As every machine do, this is our function machine, so it will process on the mathematical operations. So we can say that it's like a machine that has an input and an output, and the output is related somehow to the input. If you remember that, near about this we had given the definition of the relation also. There also input and output were related. Then how it is different from that relation? Let's understand that. So here I have taken the function f from the set x to y. What is x here? X represents the domain of the function and y represents the codomain of the function. Let x and y be two non-empty sets. The function from set x to the set y is a correspondence which associates each element of set x to exactly one unique element of set y. So in brief, I would like to tell you that how it is different from the relation. There are two important conditions. One, that every element of x, each element of the set x, must have an exactly one unique element of set y. That means every element of set x must be some association in y. And second thing, that association must be a unique one. Likewise, the function machine, if you remember that. So let this is a machine. It should not be like this, that first time when I put some x, output is different, and second time output is different. Then it is not a function. And whenever I have some input, there must be some output. That means for every x must be some association in y, and that association must be unique one. Let's try to understand this with the help of one example. So I have taken set x. Here my x is the name of some states: Goa, Haryana, Punjab, Tripura and Maharashtra. Whereas set y is the name of some capitals: Chandigarh, Panji, Mumbai, Raipur and Agartala. So I will associate the set x with the set y, and my relation will be their capital. So Goa's capital is Panji, Haryana will associate with Chandigarh, Punjab with Chandigarh, Tripura with Agartala, Maharashtra with Mumbai. So my domain will be Goa, Haryana, Punjab, Tripura and Maharashtra. The elements of the first set will be domain, because every element will have an image, so it's not an issue. So we can directly say that elements of the first set is domain of a function. And see that every element is having an image. Goa, Haryana, every state will have one capital. Okay, and that image is unique. See, Goa image is Panji. Similarly, Haryana, Chandigarh, Punjab, Chandigarh. So you cannot think that these two states have the same capital. So how it is a function? What I said, when I ask you that what is the capital of Haryana, you will say Chandigarh. This is a unique answer. When I say that what is the capital of Punjab, you will say Chandigarh. This is again a unique answer. So in that way, it's a function. So its codomain will be, the second set will be codomain, that set Y, as I told you earlier, Chandigarh, Panji, Mumbai, Raipur and Agartala. And what will be the range? Range will be the set of images, that is Chandigarh, Panji, Mumbai and Agartala. Raipur, as it does not have any pre-image, so it's not a part of our range. Okay, the function will be like this in roster form. If I write, then I will make the ordered pairs: Haryana Chandigarh, Punjab Chandigarh, Goa Panji, Maharashtra Mumbai and Tripura Agartala. So let's discuss some real valued function. A function which has either R or one of its substitute as its range is called real valued function. Further, if its domain is also real number or a subset of real number, then it is called real function. So let's interpret this. What does it mean? A function which has either real number or one of its subsets as its range. It's not talking about the domain. So real value, that means value must be a real number. So function we usually write like this: y is equal to fx. So this x is our input and y is the output, that is our value. So our value must be a real number. If value is a real number, that y is a real number, then it is to be said it's a real valued function. Further, if its domain is also a real number, then it is said real function. That means its domain and range both are real numbers, then it is real function. And if only we restrict about the range, then it is to be said real valued function. Now take an example. See, its domain is natural number, which is a part of is a subset of real numbers, and codomain is also real number, so it's an example of a real function. Let's find out the values. When x is equal to 1, then function's value will become 2 into 1 plus 1. So 2 plus 1, that is 3. Similarly, if I put 2, then it will become 4 plus 1, that is 5. If I put 3, 7, 9, 11, 13, so on. So you can check that all the values are real number. Domain is also a subset of real number. So it's a real function. Hope you got this. What is a real function and real valued function? First is an identity function. So what do you mean by an identity function? Identity means same to same. That is whatever, what will be your identity? My identity is myself. Correct. Similarly, your identity is yourself. That means whatever is the input, the output is same. So that is known as the identity function, and we will define it like this: a function where y is equal to fx, and what is that function? Y is equal to x, for x belongs to real number. So function fx is equal to x is known as a identity function. So let's check why it is known as identity function. So if I put here x is equal to minus 5, what I will get? Again minus 5. If I put x is equal to 0, then value of y will be 0. If x is equal to 3, y will be 3, and x is equal to 7, y will be 7. So now we have to find out its domain, codomain and range. For that, finding that domain, codomain and range, first let's sketch its curve. So here is the curve of y is equal to x. So now you see, children, that x-axis on x-axis, whenever I will move this point, I will get the coordinates of the point. So when x is equal to 1, y is 1, x is 2, y is 2. You can see that it's an identity function. So every x will have the same image y. And if I go to the negative side, then the same thing happens. And I can go up to infinity like that in both the directions. That means it is existing for every value of x. You can see that if I zoom out this one, we can check that it is existing for every real number of x, and up to where it will go up to every real number of y, as much we can go. So 95, 96, wherever you can go. So that means domain is all real number and range is also all real number. So its domain is all real number, codomain is already all real number, this is codomain, and range is all real number. Our next function is constant function. As its name suggests, its a value will be a constant one. So we will define the function like this. A function, its domain is all real number and codomain is all real number. And what is the function? Y is equal to fx is equal to c. So fx is equal to c. What is c? C is a constant. That means if I put -5 here, then we'll also get answer c. If I put 0, then also c. 3, c, and 7, c. Reason is my function is c. If I give the input to x -5, so no x is there, so it will remain c. Likewise, that means it will remain constant. And before finding its domain, codomain, and range, so domain, as you know, that it's a first set, that is all real number, and codomain is also given, that is all real number. Now we have to find out the range of this function. What will be the range of this function? For that, let's sketch a curve. If I took the value of c is equal to 1, then this will be my curve. So you can see that this red line is parallel to x-axis. And if I take c is equal to 2, then what will happen? It's again parallel to x-axis, but value will be 2. 3, then value will be c is equal to 4, then it will be parallel to x-axis again. Similarly, if I go to the negative side, that means in every case, this is a curve which is parallel to x-axis. So the value of y will be depending upon the what is the value of c. If I take c is equal to 2, that means the value of y, my range will remain 2 throughout the curve. Whatever the value of x may be, it will not change. The value of y will remain 2. So here if I take c is the constant function, so my range will become c. Next is a polynomial function. So what is a polynomial function? A function from R to R is said to be a polynomial function if each x in this real numbers. So this type of functions are known as the polynomial functions. In class 10th we read about the concept of polynomials. So a0, a1, x, a2, x square, so on, where the index is a non-negative integer, an x raised to power n. The n is a non-negative integer and these all the coefficients of x are the real numbers. So let's take an example. Y is equal to fx is equal to x square. So first let us find out the values of these functions. So if I take x is equal to -2, then value of function will become fx is equal to x square, and if I give the input -2, it will become -2 square, that is 4. Similarly, if I give the input -1, it will be 1, 0, 1, 4 and 9. And if I sketch the curve for this function, so this is my curve for y is equal to x square. So here if I take x is equal to 0, the value of y you can see that it is 0. But if I take x is equal to 1, then value of y will be 1. If I take x is equal to 2, then value of y will become 4, 3, then it will go to 9, so on. If I go to the negative side, then at this juncture, x is -2, y will be 4, -3, then it will be 9, so on. That means curve is existing for all the values of x. So its domain will be all real number. The only thing is that we have to decide that domain range of the function. So for the range, you can see that, observe that the function is existing only the positive side of y-axis or at 0. So curve does not go towards the negative side of the y-axis. So our range is the non-negative real numbers. So what will be our range? Non-negative real numbers. So its domain is real number, codomain is real number, and range is non-negative real number. How we will write down? We will write from 0 to infinity. Closed interval, that means 0 is included, and up to infinity. This will be the range of this particular function y is equal to x square. It's not about all the polynomial function because it will depend upon function to functions. We have infinite types of polynomial functions. So if I take x cube, then range will be different. X raised to power 4 plus x square plus x minus 2, then range will be different. So range varies from function to function. So now some rational functions. What is a rational function? A function of the type fx by gx, where fx and gx are the polynomial functions of x defined in a domain where gx should not be equal to 0. that denominator should not be equal to 0. So let hx is equal to 1 by x, and let's make the table and graph for this function. If it is 1 by x, then the value will become minus 1 by 5, minus 1 by 2.8, 1 by 3, 1 by 7, so on. So let's sketch the curve for this rational function. So this is a sketch for y is equal to 1 by x. So it's a very interesting curve. You can see that. So for every value of x, it is existing, but except where it will not exist, it will not exist at the 0. When I take x is equal to 0, function will become 1 by 0, that means infinity. Okay, you can check that if I take x is equal to 0, the curve will lead to infinity. Here some may feel that okay, it is touching the y-axis. It's not like that, dear. If I zoom it, you can see the difference. Once again, if I zoom it, you will find the clear gap. Correct. So it will lead to infinity. Similarly, if I go on increasing the value of x, curve will keep on increasing. And if I keep on decreasing the values of x, curve will keep on having the values towards x-axis. It will go nearer and nearer, but it will never touch it. So our domain will be all real numbers except 0. That denominator should not be equal to 0. And what will be the range? Range can be anything, but it will not be equal to 0. So domain is all real number except 0. Codomain will be all real number, and range will be also all real number except 0. So we already stated in our condition that gx should not be equal to 0, that x cannot be equal to 0. Our next function is a modulus function. It's a function from R to R defined by fx is equal to, these symbols are read as mod x. So modulus of x for each x belongs to real number is called a modulus function. Let's elaborate it more. So you can divide it into two parts. Where x is more than equal to 0, then function will become x. When x is less than 0, it will become minus x. So it's a kind of conditional function. So it depends on the condition of x. When x is greater than equal to 0, it will behave like x. When x is less than 0, it will behave like minus x. It's like your father tells you, if you score the more than 60%, I will give you this gift. If you score 50 to 60%, then I will give you this gift. So this is type of a conditional function. So first let us find out the values of this curve. If I take x is equal to minus 5 will lie here, x less than 0. So function will become minus x for minus 5. So what will be my value? Minus 5. Our answer will be 5. If I take 0, then x is equal to 0, I have to put here. So it will be 0. When x is equal to 3, x is equal to 3 will lie in the x more than equal to 0. So if I put here, so x is equal to 3, then it will behave like an identity function. So it will be 3 and it will be 7. So if you observe this output clearly, then what you will get? That all the values are positive. So that means y will be always positive. You can see that this is a very interesting curve. So here it comprises of two lines. First line is this y is equal to x, positive side of x-axis. And if you see negative side of x-axis, this line is y is equal to minus x. So here the values of x goes up to infinity in the positive side as well as negative side. So domain will be all real numbers, and if you look at the range of this function, so values of y is only positive or 0. So y will be non-negative real number. So its range will be a non-negative real number. So domain is all real number, codomain is all real number, range is from 0 to infinity, that is y will be always positive. It will not go towards the negative side. Our next function is signum function. So a function defined by fx is equal to, when x is more than 0, it will be 1. When x is equal to 0, it will be 0. When x is less than 0, it will be minus 1. So for each x belongs to real number is called signum function. So if I take x is equal to minus 5, then what will be the value? Minus 5 will lie this side. X is less than 0. So our answer will be minus 1. If it is 0, then if x is equal to 0, then answer will be 0. If x is equal to 3, then answer will be 1. And if x is equal to 7, then also answer is 1. For every value of x which is more than 0, answer will be 1 only. This is signum function. Here you can see that when x is equal to 0, the value of the function will be 0. So here I make the dark circle. That means at x is equal to 0, it will be 0. As soon as we will move towards the more than positive side of x-axis, when it is not 0, the value of the function will become 1. And here I use this hollow circle so that it indicates that it is not equal to 1 at x is equal to 0. So it will be whenever x is more than 0, the value will be 1. And whenever x is less than 0, value will be minus 1. So a domain that x can be all real number, codomain is all real number, but range is only 3 values, that is either minus 1, 0 or plus 1. Next is the greatest integer function. A function r to r defined by fx is equal to, this is a symbol we will use for the greatest integer function where x belongs to real numbers, assumes the value of the greatest integer less than or equal to x. Let's try to understand that. What does it mean? Such a function is called greatest integer functions. So the better way to understand this is draw a number line. So I'm drawing a number line here. Okay. Then 6, 7, and similarly we can take to the negative side. So if I say 5.5, so 5.5 will be here. What is the integer included in this one? Greatest integer you can find in this one, that is 5. Remaining is the fractional part, so we will leave that. And what about this 4.999? This will lie just near to 5. And what is the greatest integer included in 4.999? That is 4. Dear student, we are not here to round off, round up the number. We have to find the integral part in the number. If I say 4.99, that means 4 is the integral part and 0.999 is the fractional part. So we will leave that. So whatever is the fractional part, we will leave. Integer is 4. And what is the integer included here? This will be 3. In minus 2.3, many times students commit a mistake here. If I say minus 2.3, that will be here. And what is the just smallest number before that? It is minus 3. It's not minus 2. Minus 2 is greater than minus 2.3. So answer will be minus 3. It should be less than that number. See here, it is less than or equal to x. So what will be less than minus 2.3? This will be minus 3. So let's make a sketch of that. So this is my greatest integer function where you can see that when x is equal to 0, the function will be equal to 0. Or whenever it moves towards up to 1, the function integer included up to 1 will be 0. As soon as I reaches at 1, the function will have the value 1. So this will not include it. You can see that here I make an empty circle, whereas this is a dark circle. So at x is equal to 1, the function will have the value 1. And from 1 to 2, it will be having the integer 1. At 2, it will attain the value 2. Like that. So the negative side, as we've taken the point minus 2.3, so if I take the value of x minus 2.3, where you will get? You will get that value in the here. If I take x is equal to minus 2.3, then you will get the value of y will be minus 3. So what is the domain here? Domain can be all real number. But what can be the value of y for this function? Only integers. You cannot find any fractional value for the y. So its range is only integers, either positive or negative or 0, that all can be included, but only integers. So our domain will be all real numbers. Codomain will be all real numbers, but its range will be integers only. So that was about the functions. Hope you got that. Thank you very much for being with us. Thank you.